Assalamualaikum warahmatullahi wabarakatuh. My name is Fauzan Aizat bin Azri and I am here to present my individual assignment on forensic engineering. Today, we will explore three critical tools and methods used in structural integrity assessment. The first one is rebound hammer test, the second one is crack depth measurement, and the last one is the half cell corrosion potential meter. We start with the rebound hammer test. Rebound hammer test is a non-destructive technique used to assess the compressive strength and surface hardness of concrete. It operates by measuring the rebound of an elastic mass when the plunger is pressed against the concrete surface. This method is lightweight, portable, and highly versatile, making it ideal for on-site testing. Next is the type of the equipment. The first one is the carbon stone and the rebound hammer. Next is the type of the equipment. We also use the ruler to measure the point on the surface concrete and the permanent marker to mark the point on the surface concrete. We move to the features of the equipment. The rebound hammer offers three key advantages that make it invaluable tool in the field of construction and forensic engineering. First is portability. The rebound hammer is lightweight and portable, making it highly suitable for on-site testing. Its designs allow engineers to carry and use it easily in various locations without the need for heavy equipment. Second, non-destructive testing. One of the most significant benefits of the rebound hammer is that it does not cause any harm to the structure being tested. Lastly is versatility. The rebound hammer can be used on concrete surface in any orientation, whether vertical, horizontal, or inclined. This adaptability ensures that it can meet the demands of deserved testing scenario, regardless of the structure layout. The rebound hammer is an essential tool with two key applications in the construction industry. The first one is quality control in construction. Rebound hammer play a vital role in ensuring the uniformity and consistency of concrete mixture by evaluating both freshly cast and cured surface. This tool helps verify that the compressive strength standards are met, which is crucial for maintaining high quality construction practice. The second one is evaluation of the rehabilitation efforts. The rebound hammer is instrumental in arresting the success of rehabilitation or maintenance activities. By comparing rebound value obtained before and after intervention, engineers can confirm that repair area meet the required compressive strength specification. This ensures that the structural integrity of rehabilitated section align with safety and performance standards. And forensic engineering, it does have some limitations that must be considered. First is sensitivity to surface condition. The accuracy of the rebound hammer is influenced by the condition of the concrete surface. Factors such as universals, dirt, or moisture can impact the result. Second is variability due to the concrete heterogeneity. Variation in the composition and texture of concrete can lead to inconsistent result, making it essential to interpret the data carefully. The third one is they need the calibration. Different concrete mixture requires specific calibration to ensure accurate reading. This adds an additional step to the testing process. Finally, limitation the soft of thin concrete layer. The rebound hammer is not suitable for testing soft of thin concrete, as this condition can compromise the reliability of the result. Understanding this limitation helps ensure the rebound hammer is used appropriately and effectively in various testing scenarios.
Here are the procedure of operation. First, ensure that the concrete surface is free from any loose debris. Employ a carborundum stone to level any irregularities present on the test surface. Prepare the point. Use a marker and a ruler to create 12 points on the concrete surface, ensuring each point is spaced 50 mm apart. Now you can performing the test. To begin, use the hammer to apply firm pressure on the plunger against the concrete surface. Maintain a steady and gradual force until the spring mechanism releases the hammer. Subsequently, document the rebound number indicated on the scale. Lastly, proceed to repeat this process for the remaining 12 points.
Here are the result tests of rebound hammer. Next, we have crack depth measurement. This technique determines the depth of crack in material like concrete to evaluate structural integrity using tools such as transducer and calibration rods. This method ensures precise the non-destructive testing. The equipment offers several notable features that make it highly effective. First, high sensitivity to crack. It can precisely detect surface features and accurately evaluate their depth. Second, applicability to a variety of material. This tool is effective to use on major construction material such as stone and concrete. Lastly, non-destructive testing. It assesses to the depth of the fissure without causing any damage to the structure, ensuring the integrity of the test material remains intact. Other than that is a couplant. This material ensures proper transmission of ultrasonic wave between the transducer and the surface being tested. Next is cable measuring 1.5 meter. This connects the transducer to the display unit for accurate data transmission. And the last is power bank. This provides a portable power source, ensuring the equipment can be used in various locations without interruption. The equipment offers several notable features that make it highly effective. First, high sensitivity to crack. It can precisely detect surface features and accurately evaluate their depth. Second, applicability to a variety of material. This tool is effective to use on major construction material such as stone and concrete. Lastly, non-destructive testing. It assesses to the depth of the fissure without causing any damage to the structure, ensuring the integrity of the test material remains intact. The equipment has two key applications. First, forensic engineering investigation. It helps determine the root cause of failure or incidents by assessing the depth of crack in affected structure. Second, condition monitoring of aging structure. Regular assessment can identify the progression of crack in older structure over time, ensuring timely maintenance and repair. The equipment has a few limitations to consider. First, the need for a smooth surface. Proper coupling of transducer requires a clean and smooth surface. Any irregularities, dust, or grease can result in inaccurate measurement. Second, sensitivity to material properties. This method relies on well-defined and consistent material properties, such as density and elasticity, to ensure reliable results.
Procedure of operation. Once the calibration has been complete, begin by cleaning the surface. Next, establish point A and point B, each located 10 cm from the cracked surface. Subsequently, mark an additional 10 cm for both point A and point B using a couplant. To conduct the test, place the transducer on each design point where the couplant has already been applied on both sides and uh, document the result. Proceed to repeat this process to the next point.
Here are the result tests of crack depth measurement. Finally, the half-cell corrosion potential meter assesses the likelihood of corrosion in reinforced concrete structure. It measures the electrical potential difference between a reference electrode and the concrete surface, providing insight into corrosion activity. The equipment includes the following components. First, copper sulfate. This is used to prepare the solution for the testing process. Second, distilled water. It ensures the solution is free from impurities that could affect the result. Lastly, a cone breaker. This is used to prepare the copper sulfate solution efficiently. The fourth is weighting scale. Purpose used to measure the weight of the object. Next is copper sulfate electrode, used for measuring the corrosion potential in concrete structure. And the last one is digital multimeter to measure electrical properties such as voltage, current, and resistance. Features of the equipment. The first one is non-destructive testing. Identifies corrosion in concrete without inflicting any damage. Second one is corrosion potential measurement. Assesses corrosion activity by evaluating the electrical potential difference between a reference electrode and the reinforcing steel. Next is the application of the equipment. The first one is evaluation of corrosion in reinforced concrete. Facilities target repair method by identifying areas where activities corrosion is occurring in the steel reinforcement. Second one is quality assurance in construction, monitoring for any initial indication of reinforcement corrosion in newly built concrete structure. Besides that, it also have the limitation. Limitation is access to the steel reinforcement is necessary, which may involve the removal of coating of concrete coverings especially in structure that are either underground or have substantial thickness.
Here are the procedure of operation. First one, use a plastic spoon to measure 40 grams of copper sulfate into the cone breaker and place on the weighing scale. Next, pour 100 milliliter of distilled water into a cone breaker. Stir the 40 grams of copper sulfate until it is entirely dissolved in 100 milliliter of distilled water. Finally, fill the electrical junction device with resulting copper sulfate solution. Step number 5 is attach one electrode to the reinforced bar and utilize clamp to link the multimeter to the electrical lead cable. Step number 6 is apply distilled water to the bar to moisten the area where the copper sulfate electrode will be placed. Next is active the multimeter position and the copper sulfate electrode on the moist spots and choose the voltage measurement mode. Last one is document the voltage reading at each designated location.
Here are the result tests of half cell corrosion potential meter. In a nutshell, the test performed this semester utilizing the rebound hammer, crack depth measurement and half cell corrosion potential meter have yield significant insight regarding the structural integrity of concrete component. The rebound hammer proved be an effective tool for the rapid and non-destructive assessment of the concrete comprehensive strength and surface hardness, underscoring its importance in on-site quality assurance. Additionally, crack depth measurement play a crucial role in the identification and monitoring of crack, which is essential for ensuring structure safety. Furthermore, the half-cell corrosion potentiometer is instrumental in detecting corrosion within reinforced concrete, facilitating timely intervention to avoid major structure failure. So that's all for my presentation. Thank you.